So module 1, as I said earlier, is essentially to look at how to optimize energy requirement at the telecom site, because this is a very critical element. Because once you want to entirely shift from current solution to a renewable solution with your existing asset, sometimes it's not possible because of power requirement, because of your power requirement of base station, site, air conditioning, because of battery cooling facilities power requirement, and so on and so forth. So we have to always look at how to optimize the power at the site. Now, the question comes is which solution to pick? Essentially, which solution to pick in a green segment, and then what are the different site loads and how these site loads really can be translated into green solutions. Site locations. This is typically a very big problems in many occasions where site locations does not allow you to pick your desired solution. For example, in urban areas, you really want to have a site which is actually having frequent power outage, and you want to have an alternative power generation source. You can't actually think of solar. It's because maybe it's a rooftop site and you don't have enough space for doing it. So yes, essentially, site location, space availability, I just mentioned, grid availability. These are the basic 5 elements which actually has to look through while looking at the feasibility of green solution. Now, we all know that the site can be deployed with definitely pure green or hybrid green. There's nothing new about it. It's simply because a lot of people actually talks about pure green solutions, especially for telecom application. If you have a network size of 10, 15, 20 sites or 50 sites, 100 sites, and if you are really in a locations where, like South Sudan, we have been talking about South Sudan, maybe pure green solution can be really applicable there, especially if it is an outdoor site with power with a lower load requirement, with a lower site load requirement. But if you're looking at most of the other sites where the load requirement is a little bit higher side, pure green solution may be coming as cost expensive. I mean, and in many occasions, because of your autonomy requirement, your capex goes really high. So it may not be very desired approach to go for a green solution dimensioning or selection. Hybrid green is essentially having a diesel genset plus your alternative power of the generation source. It can be diesel battery plus PV, or diesel battery plus wind turbines, or diesel battery plus any other sources like fuel cell, so on and so forth. It's a hybrid approach where you want to optimize your diesel genset uses and you want to reduce the usage significantly, but at the same time you want to have a maximum uptime of your base station. So in both aspects it has to be well synced up. So hybrid solution is something that we have been seeing a significant deployment happening across the world right now. So if you check the deployment tracker and at GSMA that have been tracking the overall global telecom green solution deployment, we have been currently tracking over like 35,000 green solution deployed on green site deployed across the world, and out of those 95% are hybrid and 5% comes with a alternative other power solutions which come in pure greens. Maybe they're entirely on fuel cell or entirely on solar solutions. Now, yeah, so that's kind of like a market scenario right now, pure green versus hybrid green. Now, we also have this situation, indoor versus outdoor situation, where in the last 1 decade, indoor was predominating. And the way we see the last 2 years transition, starting from end of 2009 and last 2 years, there's a mass transition happened from indoor to outdoor. Now, we have seen it, the major telecom operators, global operators, have been doing it and swapping their networks from indoor to outdoor. Number one. Number two is we've been saying that the main of the tower companies, what they're doing is they're bringing this indoor-outdoor conversion. So it's an indoor equipment, but they're actually converting from indoor to outdoor and going for more efficiency incorporation at the site level. So the indoor-outdoor conversion is happening quite massively. This is one of the things that bear in mind that for indoor solution it's always tricky. So once you go for an indoor solution, it makes tricky for you to bring a renewable solutions, alternative power solutions, except for if you go for a solution like biomass, where the power generation capacity is quite significantly higher. Like in biomass or wind turbine, if the site is located at a higher windy area, then you get a 10-12 meter per second wind speed, you generate quite a steady amount of power, and you can still run your air conditioner inside, and the indoor site can be perfectly okay. Or in the case of biomass, where the power is produced, it's consistently, if you have a good supply chain in place and consistently generating power of about 10-12 kilowatt, it's good, it's fine. I mean, you can go ahead with the indoor sites. But if you look at the conventional, the maximum number of sites which have been deployed in other solution like solar, or maybe recently fuel cell, indoor site is not applicable. I mean, especially if you have air conditioner in place, because we have been talking about it yesterday that the indoor solution, the indoor sites, the air conditioner actually consumes about 40% to 55%. It varies from place to places of the total site's consumption. So this is very, very tricky. Now this is another big question that we get many part of the world, Asia as well as in Africa and Latin America, whether we want to extend the grid or we want to go for a standalone green solution. What does it mean? It means, let's say your site is located here and your grid is available here actually. So if you want to have your grid solution, grid power, you actually have to extend the grid, and operators has to pay for the extension. We have seen it in East Africa. We have seen hundreds of sites have been deployed through this sort of mechanism, where the operators actually spend millions of dollars to extending the grid from this location to this location. Now the question is whether it is feasible, whether this grid extension is feasible, or whether you go for a standalone power generation is feasible. Now, there are two elements which has to be considered while doing this grid extension versus standalone. Number one is, what is the availability of grid power? So let's say you are spending about $20,000 for extending the grid, but after extending the grid, what is the guarantee that you will have a consistent maximum hours of grid availability? Let's say even if you have a grid available for 10 hours, 12 hours, that's good for you. You can store the grid power and it's cost effective. But after spending about $20,000, $25,000, if your grid is actually not reliable, then is it a good investment to make, or it was not a good decision? Well, we have some examples from neighboring countries like Safaricom. They have deployed about hundreds of sites where they have invested millions of dollars to extend the grid, and we have to revisit and see what is the performance. What we learned last year, it was not good result. But anyway, so eventually this is one of the areas that we have to look at while doing this analysis, whether or not a grid extension or standalone green solutions. Now, urban versus rural, it means whether the green solutions is more applicable for urban sites or at rural sites. I think this is an old question. I mean, in a recent green deploy revolution, or I would say green advancement, I think the green solution can be applicable equally for urban and rural sites. But there is a sense that green solutions is not applicable for urban, only because the sense comes or starts from a concept that green means solar, and it is not applicable for urban sites. So once we take out ourselves from the shoe of that thought that green is solar, then I think we have the answer. So green sites, it's more feasible for rural locations. There is no doubt about it. It's because rural sites need less power, and it makes more business sense. But in terms of solution availability, we actually have solution for both urban and rural areas. Now, overall, we have a single line sort of understanding from the telecom industry, which is off-grid outdoor sites actually fits well for the green deployment, and poor grid outdoor sites fits better. What it means is, if it is off-grid site where the site is entirely off-grid, there's no grid connection, then the green solution fits really good. But if you're having a poor grid where the grid is available intermediately, let's say for 3 or 4 hours, it fits better. Isn't it a different, opposite sort of thoughts that you have in your mind? Okay, because the way it's balanced is because if you're having a site in a poor grid area, you can actually use the poor grid or the grid availability of whatever hours it is available and store it, and your alternative power solutions or green solutions can be a real alternative to back you up other hours when the grid is not available. So this is what we learned from.
I want to make one point here on the poor grid scenario, that it really depends on the transformation capacity that's available at the local grid connection point, because in some cases I've seen that you may not be able to draw as much power as you want to charge your batteries. So that's one point that you have to.
Yeah, I think that's a very valid point, that whether you can actually draw the power that you require to charge your battery. I think it's all about your site load. It's all about what is your grid availability looks like the frequency of availability. So, and of course, I mean, in most cases, if you're extending the grid, you have seen that the transformer usually is installed at the site level so that you can have the voltage level kind of steady. But that's actually a case that where you have to look at, and definitely you cannot really generalize one single statement for every location. So you have to go really case by case basis. Yeah.
If you refer to poor grid, is it blackout or brownout conditions typically that you look at?
So if I understood the question correctly. So poor grid, what we are triggering or defining as a poor grid is a site where the grid unavailability is more than 12 hours a day. So if a site is not having grid for more than 12 hours a day, it's a poor grid sites. So any definition, let's say we have seen sites. Yes.
You don't include intelligent AVR systems in your sort of green categorization now.
We do.
Oh, you do?
Yes.
Okay.
Yeah. All right, so let's look at what are the energy optimization things that we can make in place. I think these are all very common. I mean, with the people who are in telecom industry is quite aware. There's nothing newly to look at, but it's just to recap. The air conditioner is the killer here. So something that definitely has to revisit and see how you can get rid of this jammed air conditioner. Now, is there any way or not? I think it's a strategic and holistic approach. I mean, we actually have to depend on our stakeholders, our other partners. Now, if you're a tower company, you have to depend on the equipment having provided by the mobile operators. So you can't actually go back to your mobile operators and say, hey, swap it, go to outdoor. So this is actually a challenge. Now, are you the only one facing this challenge? If it is not, then can you look at the success cases where they have done some sort of transformation, having the same sort of challenges? I think this is the time you have to look at that area. Being a mobile operators, if it is a challenge, then look at how you can go for swapping your equipment from indoor to out, and how cost effective it is. I know for sure that some of the equipment vendors are actually quite aggressive of doing this swapping because it's a revenue generation stream for them. At the same time, it brings more efficiency. And we know for sure from the recent last 5 years trend from the global group level mobile operators, the way they have done the mass transition of indoor to outdoor conversion is massive. Only reason of that is the energy consumption. And there's two things. One is the BTS power consumption or transmission equipment consumption power down, degradation. And the second thing is getting rid of from the air conditioner. Now, getting rid from the air conditioner is not always always comes as easy solutions. And what we just mentioned about swapping, it's not always easy solution as well for swapping the equipments. Now, what we do is, what we suggest our stakeholder is, can we bring something intermediate? Can we do something which can still cool my equipments? That means control the environment at the same time reduces my power requirement. So I think we have some answers. I mean, we know for sure that in many locations the free cooling can be a good sort of answer. But again, it is not an answer for all sites. Remember, none of the solution fits 100% accurate for all sites. Free cooling can be fit for. You have to go revisit your network and see where it can fit well. But I know for sure that free cooling have been deployed thousands across telecom operators. Thousands and thousands. It's a double and triple digit thousand actually. free cooling unit has been deployed in telecom. So that means actually it is working, it is performing, and people are happy about it. But again, you have to look at where it is deployed, what are the scenarios, and which are the cases it has been deployed. So you can't actually have a ambient temperature of 46 degree and your BTS, you have 2 or 3 tenants inside a shelter, and you can't having a free cooling unit there, because eventually your TRX will shut down in half an hour, 1 hour. This is a scenario, and you can't actually have a free cooling unit at that scenario. So we know this. So you have to go case by case basis. But free cooling is a very good solution. So we have seen it even in Egypt. You have seen it in Middle East, where the ambient temperature is very high, but the free cooling is performing very well. Now, many occasions the free cooling was coming up with air conditioner. So it's air conditioner plus free cooling with an intelligent adapting system adapted there. So we actually is controlling both of the equipments, and it's reducing the air conditioner requirement quite significantly. Now, DC air conditioner is another good answer. Now, DC air conditioner is not very sort of common solution deployed in telecom. Now, we have seen the DC air conditioner have been started deploying, but the number of deployment that happened DC air conditioner is quite limited. I guess it's simply because the free cooling unit got a good traction, and free cooling unit deployment happened quite significantly. And then second part is the network swapping from indoor to outdoor. This swapping actually happened quite a big number. So the DC air conditioner didn't get much traction, but DC air conditioner is one of the solution. So yeah, this is looking at energy optimization on the air conditioner part. Battery cooler, yeah, I think the battery guys is here. Well, this is one of the reason of having air conditioner. We all know. The first question, if you are a mobile operator, the first question you will ask me is, you know, if I'm not having air conditioner, my battery will drain out, and I have to replace my battery in 2 years. Well, yes, it is. This is the scenario. So if you're using a regular BRLA type battery, and it's very temperature sensitive once the temperature goes higher than 22 degrees. So eventually you have to look at environment control opportunity, and eventually you have to have some conditioner system in place. Now, do you need to have a air conditioner for the entire shelter only to cool down your battery? No. So the battery shelter is one of the solutions. And we have been suggesting battery shelter as a solution for the last 5 years. I know for sure the many of the operators has deployed it, but we know hundreds of the operators haven't done that yet. I think now this is a time when we have smart batteries, which is not temperature sensitive. We have some batteries which actually needs temperature in order to perform, like some of the battery manufacturers have that, maybe a GE's battery. And then we know for sure some of the batteries which are it's called HTC, high temperature HTP, okay, high temperature battery, which performs 100% well in a higher temperature. So I think selecting of battery is one of the key areas here to look at. At the same time, if you're dealing with an existing site and you can't actually go for replacing your existing battery, then you have to look at, instead of cooling the entire shelter or entire BTS room, can you just cool your battery shelter or battery cabinet? If you can do that, that's one of the best way of reducing your power requirement. And battery cooler for sure it's a very number one, cost effective. Number two, the power requirement is quite low. We know even in the old battery cooler which came in the market about 5 years ago, those consumes about 150 watts, 200 watts. I know for sure the new generation consumes very lower than that, maybe 50% of it. And I was getting one of the presentation yesterday, and we saw it from that presentation that the battery cooler was taking a much lower power. So this is one of the way of reducing your power requirement. Sorry.
There are some radios in the equipment room, like a country like Uganda, we don't have transmission maybe from the government. The transmission is done using radios in the room. So we found out that these radios shut down even before the temperature reaches 27. They shut down. So we wanted to try battery coolers, but we couldn't because they are shutting down.
This is an interesting feedback. Now, we know for sure that the transmission equipments are still indoor equipments, nor outdoor. So I know that the vendors are looking into it to look at outdoor transmission equipments, but if you look at even any of these equipments, what is advised or what is, the product spec says it can work really fine up to 65 degrees. So if some equipment is not functioning in 27 degrees, you definitely have to revisit to the manufacturers and say, guys, what was the commitment was from there and what is the performance? So I think this is one of the cases that we have to definitely see what are the core reasons of not performing, and probably we have to visit with the manufacturers. But we know from the field experience for sure that the telecom equipments, including the transmission equipments, performs very well even at the temperature of 40 degrees or 45 degrees. But this is one of the cases that we definitely should look at closer. Yeah.
This is an interesting
Mostly
scenario. Actually, I've noticed that in some of the countries we work in, and despite with the operator swapping the indoor equipment outdoor, they have to put the equipment inside the shelter just because they can't move out their transmission.
No, I mean, this is actually quite an interesting thought. So let's put it in this way. This outdoor cabinets that usually comes with your BTS, or even there existing, multiple outdoor cabinet manufacturers, what they do is they have a free cooling or natural cooling units in place. And you can actually literally put your indoor unit of your transmission equipments or your whatever mux for optical fiber, you can actually put it there and it works. I mean, we have seen it in some situation in Middle East where the temperature is really high and it's performing very well. We actually have seen it hundreds of cases this in South Asia, so even in Latin America. So we really want to see what are the core reasons, and this is something that we need a close coordination between operators and the manufacturers, and we'd love to take the lead to see what are the core reasons behind it. But yeah, of course, we have to visit and see what was the product specification saying and what is the actual performance making on the ground.
Yeah.
And on most of the sites, we have more transmission than the BTS equipment. You find the OSN radios, and they're consuming more power even than the BTS, and they're giving off a lot of heat.
I completely agree. So we are in such a situation where, especially in Africa, where I mean, let me share my experience. We had some project with one of the East African countries, and we realized that the equipment was being installed there in 2011 is actually something we usually don't see it installing some other part of the world, because it's actually kind of like the generation of that particular equipment was actually 5 years old, and now in the market the more efficient equipments are in place and more less power consumed equipment are in place. So I see a clear reason why this sort of things are happening. I think it's more about how you plan your investment, overall network infrastructure deployment investment. If you are actually looking at in a long-term investment, in a 5 years investment prospects, what you're currently making it, I think it is always wise to see what is the current product footprint looks like. And if you see the last 5 years heat dissipation rate reduced for about 27% to 34% from telecom equipment. The footprint reduced, heat dissipation reduced, so and internal electronics power consumption reduced. So last 5 years telecom equipment is suggesting that the power requirement reduced for about, in many cases, about 75% power requirement reduced. Heat dissipation reduced for about 27 to 34%. Footprint reduced about many cases 80% footprint reduced. So it all indicates the equipments which are coming, which started coming for the last 3-4 years, are more efficient. Now the challenge is with the existing equipments, which you have installed about 10 years ago. Right. So now it's probably as a time to see what would be the best approach, what would be the best way of, if you're continuing using those equipments, how it can be more, what would be the best way of, making a efficient energy utilization for those equipments, if we can swap it. And if we can swap it, it's a different story though. So yeah, but would love to see, probably we can take some lead and see what is exactly happening there and what are the best way we can recommend or maybe suggestions.
On the free air cooling, basically what I've seen in the past is the indoor shelters are typically very congested. And if you do free air cooling, you should investigate like the normal cabinets 42U cabinets that have the side panels and everything. So if you want to implement free cooling, you should remove the side panels to force that free air over the equipment. And typically as well, the units are installed right on top of each other, so there's no a possibility for the air to flow over that equipment. So then within a cabinet you get thermal running away, but the rest of that cabinet is actually quite good.
Yeah, this is one of the case.
Yeah.
This is one of the case where you can actually install free cooling. It's simply because you mentioned 2 points here. One is the congestion. I mean, your BTS room is fully equipped with equipment, so you don't actually have a space where the cooling can be, the air can be flown. So eventually you can actually have free cooling there. Now there are multiple ways of installing free coolings. There are, one of the way is, it actually goes directly to your cabinet. And it kind of works like an exhaust and collect the hot air from individual cabinets. So there are multiple ways of doing it. So it's all about how you are reaching out to multiple vendors and getting multiple sort of products. We have seen it. We are seeing it in every day. And the free cooling, not only free cooling, the overall cooling technology actually improved quite significantly in the last few years. Quite significantly, and it is not about for data center, but also for your office, entire corporate office, but also for about telecom equipments and base stations. We definitely need to see the multiple solutions. We shouldn't be only restricting ourselves to look at 3-4 vendors' equipments. All right, we need to make it a little quicker. TRX utilization is one of the way of optimization. It's applicable for mobile operators. In most cases, this utilization happened in a smart way. We have seen it in most of the large operators or group level operators. They have implemented it. What it means is once the TRX is not utilized, if you're having lower traffic, your TRX automatically shuts off, and then it turns on once you started getting more traffic to your other TRX. So by that, you can actually enhance the, increase the opportunity for reducing your power requirement during your low traffic hours. This is on place. I have seen it in many of the operators. I would say most of the operators have installed it. And this works very well with all the new generation equipment, with all the telecom equipment vendors. Ericsson, ZTE, Huawei, Alcatel, and everyone provides this. Okay, this is a small topic, which is energy efficient light. Okay, so energy efficient light, the reason why we put this is we have seen, especially in the greenfield sites, what we've seen is in the greenfield sites, people are providing like about 200, 400 watts, very flashlights at all the corners or all the boundaries of the BTS areas, and it's like flashy, and throughout the 12 hours of the evening it's actually burning, it's consuming a lot of energies, and having those lightings. And question is, yes, you need a light for security for sure, but do you need those flashy flashlights, or you can go for more efficient lights? And this is, probably it will look a small component for you, but if you have a network of 5,000 base stations and just go and do a network audit and see how much power is consumed every year, it's quite significant. You can actually replace those to lower power required bulb, and then it can eventually save a lot of your power. And this is one of the small ways of reducing your power requirement, and that enhances the possibility of green deployment. Site security is a very, very critical element here. Now, you have to increase your site security component in order to go for green solutions. Why? Isn't it coming as the opposite component? People say that if I install solar, I'm more secure. I don't have to worry about a diesel genset. True, but I'm not saying having a physical site security. It's about the security elements that you have to make in place. It's because you have to constantly monitor the site's activity. Now, this is very, this is an important topic for African countries. Maybe some of the Asian countries having a better situation, and especially Central Asia and Southeast Asia.